Right, so yeah, let's talk about Git and Git-like things. So everybody here uses computers in some form or another to do schoolwork, to either store code or homework problems or notes or things like that, right? So here's a typical scenario. I'm working on a project here. I've been doing this for 6 months, right? I've got source code files.java, I've got readmes, I've got to-do lists in here, I've got documentation, I've got data files, I got all kinds of stuff, right? And we usually have some way of doing backups ourselves. We make a copy of a file and so on. So one thing I do is when I'm going to make changes to a file like fft.java, I'll copy it into an fft.java.old, right? And then if I change fft.java and I totally mess it up, I can go back to the old version, right? So the longer you work with computers, the more inevitable is that you'll do something like this, usually at 2 a.m. Here's all my code, and I've got my project finished. It's in exactly the form I want. I'm cleaning it up now. I want to get rid of all my .old files because I don't need those anymore. So I say rm star.old, and I get an error for some reason. Oh, because I forgot to say dot. So I say rm star.old, and I can't find it. And why not? And hey, all my stuff is totally gone, right? And it was one typo. Instead of saying star.old, I said star space old. The star matched everything. And now your brain starts going at like 10x, right? And it's like, okay, so where can I get I'm in my work directory. Okay, can I undelete something, right? And you're basically out of luck here, right? And that's a horrible feeling. So you hope you got something on a flash drive, or you got printouts of your code, or you start from scratch and you rebuild. And if you don't have really good habits as far as putting different pieces of projects in different areas, right, you've just wiped out your life's work, okay? So that's potentially a bummer. So if I do git ls-files-d, because I was using Git in developing my project, I can get a list of all the files that I just deleted, right? And I can say the following, and magic, my files are back, okay? That's one of the key ideas of using Git. It's the idea that you have a way to back up your work so that if something happens, if you either delete one file or maybe delete all of your files, you haven't actually lost your work. There's a way to get it back. So Git is a few things. One, it's an archive system for saving copies of your work. Two, it's a source code control system, which is a fancy way of saying it's useful if you're making different versions of code, right? And again, 2 a.m. experience, you've been trying to get this program to work, it's almost right, you think you know how to fix it, and so you delete a million lines of code and you start writing random stuff, and you look at it in the morning and it's like, this is garbage. I want my old version back. Well, if you didn't save it, right? So if you're using Git, it can save old versions for you. It's very easy to go back to the old version, or go back to the newer one after that, or look at the differences between them and so on. The third thing Git does for you is collaboration. So it's possible to have a project that multiple people are working on, and you can create what are called branches, and each person can make their own version of this project, make changes to it, test it out, and so on without affecting anybody else. And then at some point you can say, okay, I've got the best version of this, you've got the best version of that, let's merge them together. And Git was developed for when Linux was being written, which was, thousands, tens of thousands of programmers, all trying to share a common code base, develop, collaborate, and so on and so forth. And they were using a free of charge source code control system that suddenly decided to start charging. And they were like, no, we're done with that. So they wrote their own source code control system, Git, and it's still with us today. So let's play around with this. So let's start in a truly empty directory. So I'm just in this. Actually, I'm going to do better than this. I'm going to hop onto the Linux server, which I've completely cleared of any experience with Git. So this is completely what it would look like if you were just doing this on a fresh system. So let's go in here. So I've got an empty directory. I've got no files. All right, so first thing, when you start using Git, you have to do a little bit of initial setup. Okay, you have to do this one time in your life when you first start using Git on a new machine. So there's a bunch of configuration commands: git config, global user.name. And you got to have a username for this, and this should be a name that you're eventually going to use on GitLab or GitHub. So it should be something unique. I'm going to call myself ECS Club because I checked last night and that was available.
You can't use something that other people would use?
No, it should be unique. If you're going to put this out in the cloud, if you're just using it on your machine, that's fine. But eventually you're going to want to put stuff on GitLab or GitHub.
Right now?
So right now, I'm still just on my machine, okay, but I'm basically telling my system what's my username going to be when I use Git. So that's going to be my username, and then user.email. Let's go with this. I think that's available. And if you like VI, which you should, this should have been email. If you like VI, you can set up your editor, core.editor, VI. And there's things where it will bring up an editor for you to do stuff, and by default, it's a different editor. So if you like VI, do that. All right. So I want to start using Git. Okay, so this you do once in your life, okay, per machine. Now I'm in a directory demo and I want to start making some code and I want to put it under Git control. So one time per project, here's what you do: git init. Okay, this creates nothing that you see with ls, but it creates a hidden directory .git. Stay out of that directory. Okay, if you go in there and you tinker with things, you can wreck your entire repository, and all the magic that Git does for you goes out the window. So pretend that directory isn't there, but it is. Back it up if you're making backups. But when you do an ls, you don't see it in there. All right, so let's make some files. File 1. Okay, so there's my first program. And here's my second program. And here's a .h file. All right, so I got 3 files here. All right, so there's a concept in Git called a staging area. Okay, so here's the idea. We've got files in our directory. Ultimately, we want to put them under Git control, so we want to put them into what's called a repository. There's a spot in between called a staging area. Basically, you take the files you want to put in the repo, you move them to the staging area, and then you say, take everything in the staging area, commit that to the repository. So it's always this 2-step process. So to put these on the staging area, I can say git add, and I'm just going to say star because I just want to add everything in this case. Okay. Didn't seem to do anything. You can always say git status, and it'll tell you what's going on. Okay, so the main thing here, changes to be committed, 3 new files. Okay. And if I want to actually commit those, I just say git commit. And now it brings up an editor, VI, because I said core editor is VI. And I have to type a message here saying why I'm making this commit. What did I change, and so on and so forth. If I leave that blank, it won't actually commit it. So you got to at least type a dot or a space or something. So I'm just going to say initial check-in of super cool code. And now it's checked 3 files in. And there's nothing different in here, right? I still have my 3 files. But if I say git status, it'll say everything is up to date, right? Working directory is clean, nothing to commit. So I'm going to edit my file 1.c, and I'm going to make this something better. All right, and I want to save that change too, so I'm going to say git add file 1.c, git commit, and my comment here is change the code to be valid C. All right, my git status still says working directory clean, nothing changed. I've still got 3 files here. But there's a history now of what I've done. Okay, so I can say, for example, git log, and I see the following. I did an initial check-in of super cool code at 12:14, and then at 12:15 I changed code to be valid C, right? And so I've got two versions of my code. And if I want to go back to the old version of the code, I can do the following: git checkout, and you don't need to type this whole number, but I'm just going to copy and paste that magic hex code. And now I'm at initial check-in of super cool code. And if I look at code1.c, or what was it called, file1.c, right, it's my original version with the typos and all that sort of stuff. If I say git checkout master, that brings me back to the actual current view that it should be. And now if I look at file1.c, it's the newer version that I had written. So I've got version control, okay, and that's one of the keys here. And if I accidentally remove that file, right? Oh, I didn't mean to remove that, right? Git checkout file1.c brings it back from the repository, and there it is again. So you have to develop a little bit of habit, right? When you make some changes, you need to do a git add and a git commit. You can put that into an alias or a script, or you can make aliases inside Git, or you could modify your edit command so that every time you come out of your editor, it automatically adds and commits, which would be pretty extreme, right? Or you can make a one-line command like A, and you hit A and it does a git add star git commit with a default message. And now you've always got a way to go back. Okay, so that's one aspect of Git. If someone steals your laptop or if your hard drive crashes, this doesn't do you any good though, unless you've backed up your .git directory and everything else, right? So the other big benefit of Git is that there's support in the cloud for this. Okay, so do you have a question, or you just?
Yeah, I got a question.
Yeah.
Once you put stuff on your repository, is it up, like open to the public?
No.
No.
So at this point, everything is just on my laptop.
Okay.
Okay, we're about to go into the cloud
Okay.
and put this up, and we can make repositories public or private.
Oh, okay.
Okay. So GitHub was sort of the oldest, most used repository out there. I didn't like GitHub because all the repositories were public unless you paid a monthly fee to get private. I don't know if that's still the case, but then Microsoft bought GitHub for like $7.5 billion, and people kind of went fleeing to the hills from GitHub in some cases. So I stumbled across GitLab, okay, and GitLab is widely popular, but it allows private repositories for free, okay. I believe it's all open source, and you get 10 gigabytes of storage per project,
Ooh.
right, unlimited.
How much is a file usually?
File is
Megabytes?
so when you do an LS, that 30, that's how many bytes are in that file,
Oh,
right? So 30 bytes out of 10 billion,
wow.
right? So it's a little bigger because there's housekeeping, but so you can't use it, for example, you don't want to upload your movies there because it's not something you can stream from, right? Plus they might get upset if it was, but for code, right, it's effectively unlimited storage in the cloud, which is pretty cool. So let's set up a GitLab account. So gitlab.com.
So is it GitHub that you're using on your computer, but you don't like it to GitLab?
So on your computer, you're just using Git.
Just
Okay, Git is just a tool. It's part of Linux. You can get a version of it. Stupid content tracker.
Is it built like into the console or the terminal?
It comes with Linux by default,
Oh, really?
as far as I know. Yeah, I don't think I installed it. So yeah, so this is purely on my machine so far, and nothing to do with GitHub or GitLab or anything like that. But part of Git is you can set up a Git server, and you could do this on your own machine, and then push things from your laptop to your server in the basement or whatever, right? And GitLab and GitHub are just servers that are out in the cloud that we can get to, and you can set up accounts and use. All right, so here's GitLab. So you have to register for an account. Okay, so I'm going to, I'll actually use my name. I'll call it ECS Club. And bicycling 2. So the username will be public, yeah.
So we have to choose wisely.
So choose wisely. And I'm not a robot. Yeah, I use Nick Macias for my actual one. All right, so we register, and it's going to send a confirmation email request. So grab your email and confirm your account as usual. And we're good to go. All right, so now I can log in, ECS Club, super secret password. All right, so here I am on the GitLab website. And I would like to take my project that I've been working on my laptop and push it over to the cloud. Right, 1, because it's off-site storage. And 2, so that if I'm at school and I didn't bring my laptop with me, I can hop onto another machine, I can come over here and I can download my repository and continue working here. All right, so here's one of these one-time in your lifetime things. Yeah?
Is a repository just like another word for a database?
Basically, yeah. It's just a place where all of your files get stored. All right, so one-time thing to do. And if you don't do this, it will tell you you can't do anything until you do this, and it'll actually take you through instructions for it. And I have like a one-page summary I can give you if you want. So I'm going to click on this thing and go to Settings. And I can come down here to where it says SSH Keys and click on that. Okay, I'm going to be taking code on my laptop and pushing it up to here, or pulling code from here down, right? Pushing code up to here. And you don't want other people pushing code into your repository, right? So you want to make sure it knows that it's you who's pushing the code. You don't want to have to type in a username and password every time you do this. You want to just be able to say git add, git commit, git push, and be done. So you set up an SSH pair, okay? So you put a file in your laptop, you put a file on here, and those 2 files will be used to authenticate that it's actually you. Okay, so you can click on instructions to generate one, and it'll tell you how to generate this key pair, right, depending on what operating system you're using. But I've already done this a few times, so I'm just going to go ahead and, so SSH-keygen, that's a dash. Dash T says, here's the type of key I want is RSA. That's a pretty weak but reasonable encryption standard. Well, it's actually not that weak. Block size is 4096. This is just stuff that you hardwire. Dash C, I don't remember what it means. Then I'm going to put in my email address. So bicycling2@cellmatrix.com. And it'll do its stuff and generate a pair of keys. Right, so this is public key encryption. So there's a private key we'll keep here. There's a public key we'll put up. File in which to save the key, just take the default. If it says it already exists, you want to overwrite it, just say yes. Passphrase is another level of security. I usually just leave those blank. There's a thing I can put on the bottom of my email to impress people, but it's created this public-private key for me. So I've got a directory called .ssh, and it's got IDRSA and IDRSA.pub. Okay, pub is the one that I can share with other people. The plain IDRSA, that's the secret one. So you don't want to give that to anybody. So I'm going to cat IDRSA.pub. And here's my public key. So I'm going to copy all of that. And I'm going to paste it into here. Got some spelling errors, that's okay. And you can make your title whatever you want. And I'm just going to say add key. Okay, so at this point, I can push things from my laptop to this repository and it'll automatically know that it's me. Okay, because I'm the one who's got the private key that corresponds to this. All right, so we're all set there. Let's just go back to the home page here. All right, so in this case, I've got a project sitting here. You can start your project on GitLab, you can start your project on your laptop. I've already got a project started here. I want to push it over to GitLab. Okay, so here's the one command I have to use. Git remote add origin git at gitlab.com colon username ECS_club slash, and then whatever I want to call this repository. I'm calling it demo here. I'm going to stick to that. I'm going to call it demo, and you put a .git after it. Okay, and this, I don't know what happens if you change some of these things, right? But if you don't change them, this should work. So git remote add origin is saying take what's in my current directory here, and let's add that to the repository online. That's what origin means. There's how we get to the server. There's my username on the server, and there's what I want to call the repository. So one command does that, and then if I come over here and I look at projects and look at your projects, I don't have any projects yet. Do I have to push? Ah, yeah, okay, one more command, git push origin master. This is the one you do anytime you want to sync your repository up to the cloud. So git push origin master, it's fairly efficient, it spits out lots of stuff, but now if I say projects, your projects, there's my demo. And it's got a little lock on it which says that it's private. Okay, so that's my default. But if I click on that, there's my files, file 1 and file 2 sub. I can click on file 1 and there's what that looks like. I can click on the comment and I can see the history of changes. So this is what was in there and this is what's in there now. And I can click on history and see my history of check-ins. Or if I click on a file like file 1, I can say show me the history, right? And I can go back to the initial check-in and there's the original, and so on and so forth.
Can you only do this with like documents or text file that you created in like the console, or could you back up like Word documents?
Yeah, you can do pretty much anything.
Okay.
Whatever you add with git add will get pushed over here. It can be binary, right? So like a Word document or a PDF or things like that. It all pretty much works.
Okay, so I got a question on this.
Yeah.
This is like GitLab is just a server you can store your stuff on for backup.
Mm-hmm.
On the GitHub application, it has all that commit and push, where it pushes it onto a server too. So does this GitHub have a server of its own?
GitHub has a server, yeah. GitHub is effectively totally separate from GitLab, right? They're two completely separate services.
So what's the benefit of using GitLab?
I don't know if there is one. You got to double check and make sure GitHub supports private repositories for free. Okay. And then if you're okay with the fact that Microsoft owns it, which, you know, is probably pretty safe. But, you know, they bought Minecraft too. And so I got into the habit of GitLab and I've just stuck with it because I haven't had a reason to switch.
Okay.
But all of this is synonymous with things that you would do on GitHub.
Yeah.
Set up the SSH key and so on and so forth. And the commands you would use on here, right, will be the same.
So but GitLab is most useful for people who want to stick to console, right?
I don't think it makes a difference, actually.
Is it? Okay.
Right? I mean, the only reason I went with GitLab originally was because at the time GitHub didn't support private repos for free.
Oh.
Right? So unless you paid money, everything that you did was pushed up there, was available for anybody to see and copy.
Right. Okay.
Which one's aesthetically more pleasing, in your opinion?
I haven't used GitHub much, so I don't know how it would compare. And if you go online, right, there's gigabytes of discussion forum around this topic, right? Which one is better? Which one's got more features? And it's
Oh, so
VI versus Emacs. Or
So that account that you made for GitHub, was that actually for the GitHub page, or is that just for?
so that account I made was on the GitLab server
No, not that GitLab. The one in the console.
in the console. So that was
Email and everything.
So that gets used by my local copy of Git running on my laptop, right?
Oh.
When I said git config and I gave it my email, right? But that's what's also being used now when I push things over to the server, right? So I log in with bicycling2 as my name and so on.
Okay. I think I understand.
So if you were trying to set this up with like a PC, I guess, would you need to get like a terminal that can support Linux?
There's
Or-
software that does all of these commands for you that'll run under Windows.
So if you do like virtual studio or something, would there be like kind of like plugin probably?
Usually, I mean, like Eclipse has a whole back end for supporting Git. I'm pretty sure that IntelliJ does, and most of these tools make it pretty painless, right? You can be editing some stuff, you hit a button, and everything gets like pushed over.
So what's the difference between a project?
A project and
Like there's a shared repository that people work on.
so I'm using project kind of interchangeably. Repository, I'm meaning an area where stuff gets stored.
You can
Right.
make it editable by people, yeah?
Yeah. So if I look here, yeah, so it calls them projects, but I call them repositories. I think they're the same thing. Yeah, you're right. They call them projects.
Okay. Same thing.
Same thing.
Yeah, because I'm using the GitHub app, and it seems like it does everything that you went over,
Mm-hmm.
except it does not include console or anything, and it deals with its own GitHub.
Right.
So it seems like you were doing more like.
Yeah, it's probably just a graphical wrapper around, point and click wrapper around all these commands, like most things.
I see.
Okay. So another thing I can do, so pretend I'm on a different system here, on a different laptop. I have no code sitting here, right? And I know that this project has been checked into GitLab, and I'd like to make a copy of it here. I can say Git Clone, git at gitlab.com, :ECS club / demo.git. And now I've got a directory in here named demo, and if I go into there, there's my project. So with a couple of commands with Git Clone, right, you can say, take this repository that's up on the server and use that to make a local version of that whole project on my current machine. And this is nice because, you might have a laptop you're working on at home, you might have a laptop you work on somewhere else, and you might have a server that you log into and run things on, like Linux, engrcs.com. And you can have code development happening on all three. When you're done developing your code, you push it out to the server. When you get home to your laptop, you pull down from the server and you continue from there. And it's very easy to sort of push up changes and pull down changes and keep everything in sync. So for example, I'm on my second laptop here, right under my project, and I'm going to make a README. And I'm going to say git add readme, git commit, edit a readme. And then if I want to push these changes to the server, it's always git push origin master. Okay, origin is the cloud-based thing. Master is what's called the branch. It's my current version. version. It's just git push origin master every time, every time, every time. And now if I come back here to my original version, right, which doesn't have a README, I can say git pull origin master. And now I'm up to date. I've got my README in here. And of course, if I look at my project on the repository, that's going to include the README. And there's lots of things you can do. You can do git rm to remove a file. You can do git mv to move a file or rename it. And it updates all of its internal housekeeping accordingly. Does that make sense?
Yeah. Nice, okay.
All right. Do you want to know about branches? It's probably another 5 minutes.
It's like the updates you made to it, right?
So branches are this idea of if you want to have 2 or more versions of your project without having to take everything and start like a whole new project.
Every time you push, does that create a branch?
No, every time you push, it updates the repository online with what you've got in your local repository, right? It just synchronizes your project basically. But if I decide I want to make a change to file2.c, I can start editing it, right? And I can push it up to GitLab, but anybody else who pulls files down, they're going to see what I just pushed up there, right? And maybe you're working on one version of file2, maybe I'm trying something else on file2, and we both want to make our own sets of changes to it without stepping on each other's work. Because you stay up all night, you make a bunch of changes to file2 and you push it up there, and then I come along in the morning and I take my file2, make one change, push it up, your version has been overwritten.
Oh.
Right?
How will you make a branch?
So to make a branch, so let's stick with this demo directory. So I've got these 4 files. Really easy, git checkout -b, and I'm just going to call this try it. Okay, so switch to a new branch called try it. All the files are still here, okay, but I can say file2.c. I have a brilliant idea. All right, so there's my brilliant idea. Don't actually run that, okay? It's a classic fork bomb. So I take that and I say git add file2.c, git commit, oops, git push origin master. All right. Okay, so I'm on a branch. So git push origin try it. So normally your branch is called a master branch, right? I'm on a new branch called try it. So instead of git push origin master, I'll say git push origin try it. So I push that off. Okay, I've got my code here. I can make more changes. I can add everything. I can commit, make my silly commit message, git push origin, try it. So I'm doing my development here, right? Meanwhile, you are still on your original branch. So git checkout master. This is what you're going to see. Same files, but file 2 is, whatever it was. But me, I'm on this other branch. Called try it, right? And I see this code. So now you're developing your version of file 2, I'm developing my version of file 2, and I can push mine up, you can push yours up, right? And they're not going to collide with each other.
Really quick, what is even the fork, whatever you just called it?
Oh, yeah, so fork says make a copy of the current process. And if you put that in a loop, it'll crash your machine really quickly.
Oh, really?
Because each of those copies now is still inside a while loop, and they each make 2 copies. And so it takes like half a second to run out of process space. Yeah. You can try it on your own machine, though. All right, so if I come back here and I look at my demo project, right, I can click on this and it shows me there's 2 branches. So I can look at the try it branch, right, and here's what file 2 looks like. Or I can go and look at the master branch, and there's what file 2 looks like. And you can have as many branches as you want. So typically you have different developers working on a project. Each one creates their own branch, does their development, and so on. And then there's ways that you can say, okay, let's take these changed versions and combine them together. And that gets slightly creepy and sometimes problematic. But you can use a merge statement and say, okay, let's put these together. If it can do it in a way that's pretty unambiguous, it will do it. Otherwise, it will basically say, I need help. And it will give you a merged file that has pieces of both and some comments in it to help you figure out how to manually put them together. But if you're just, you're working on the part of the file and someone else is working on that part of it, it'll put them together pretty cleanly.
Do this like look at the line number and then just merge them together?
Yeah, but in a smart way, right? So if you ever use the difference command on Unix, difference is smart. So you typically have 2 files. You want to know if they're the same. Well, if you put 1 extra character in this file and you're just looking character by character, it looks like the files are totally different, right? So the difference command will say, okay, this is the same. Oh, this character is different, but after that, everything's exactly the same. And they'll say, okay, there's only 1 difference. There's 1 extra character here. So it uses that kind of approach to say, yeah, the 5th line here is not the same as the 5th line here, but the 5th line is the same as the 7th, and the 6th line is the same as the 8th. So all that stuff is the same, and it'll tell you just what the differences are. And based on that, if it can merge them together, it'll merge them. Yeah. And so we do group projects in the CS sequence, and some people use Git to collaborate like that, and it works really well. All right, that's my 40-minute overview of Git.
Thank you so much.
Yeah. When you're first messing with it, just don't use anything precious, right? Always make your own backups, right? Just copy everything or make a tar file or stick it on a flash drive or something and then start messing with it. And inevitably you do something slightly different and it might, not want to restore your files or something. But you can always come into here and if you've got a file, you can just say download and you can pull it down like that. If the repository structure isn't to your liking, you can pick out individual files and pull them down. So it's pretty robust.
Thank you so much.
All right, you're welcome.
Appreciate it.
I'm going to delete my account now.